In this video, we are going to talk about how to calculate the number of covalent bonds in an alkane or alkene or alkyne. Is there any general formula to calculate this? That's what we are going to talk about in this video. Let us first discuss alkanes. Alkanes are hydrocarbons with the general molecular formula CnH2n plus 2, where n is an integer that we know. Let us say we were given the molecular formula C2H6 and we are asked to calculate the number of covalent bonds in C2H6. What we normally do is we write down the structure and then calculate the number of covalent bonds. So in this case, the number of covalent bonds equal to 7. Yeah, we have 6 CH bonds plus 1 CC bond. That's what we have here. So total 7. Now, based on the valency of carbon, is there a way to arrive at a general formula to calculate this? Before doing that, we first need to understand the concept of shared covalent bonds and unshared covalent bonds so that we can understand the general formula easily. So let us say, for example, we know that the valency of carbon is always 4. Okay, so 2 times 4 equal to 8. But do we have 8 covalent bonds here? No, we don't have 8 covalent bonds here. We are only having 7 covalent bonds. Why? This CC bond that we have here is shared. When we count the acted rule for each carbon, so there will be 3 CH bonds and then 1 CC bond. So we will be counting that, and we are when we are counting the acted rule for, when we are checking whether this carbon also obeys the acted rule or not, that time too we will be counting this CC bond. So that CC bond is always shared. So if we can subtract that value, then we will be getting the number of covalent bonds accurately. So let us put the formula like this: number of covalent bonds equal to 4 times n. Why 4? Because the valency of carbon is 4. Okay, valency of carbon times n minus n minus 1. This n minus 1 will give us the number of shared covalent bonds. Where n is an integer. Okay, so usually it will be equal to number of carbon atoms. So you can directly write it as number of carbon atoms. Okay, so let us cross check that. For C2H6, 4 times 2 minus 2 minus 1, so 1, so 8 minus 1, 7. Let us cross check that for a higher elemental composition. Let's say we were given C5H12. Okay, in this case the answer should be 16. Whether we are getting 16 or not, we will just cross check that. So 4 times 5 minus 5 minus 1. So 20 minus 4, that is equal to 16. You can also cross check it by writing the entire structure if you want to. So just bear with me on this. So we basically have 4 CC bonds. Okay, 4 CC bonds are there. That is number of covalent bonds, and then the remaining 12 CH bonds are there. So total 16. That's what we got. Yeah, that's what we got. How about alkynes? Sorry, how about alkenes? So let us first finish alkenes. So for alkenes, the number of covalent bonds equal to 4 times n minus n. So let us say we have this one, ethylene. The molecular formula is C2H4. General molecular formula is CnH2n, that we already know. So 4 times n2, because here the value of n is 2, and then 2 here. So 8 minus 2, that is equal to 6. We have 6 covalent bonds here in this case. Yeah. Let's move on to alkyne. Alkynes are molecules with the general formula CnH2n minus 2. So here the number of covalent bonds equal to 4 times n minus n plus 1. Let us cross check that. Let us say we have acetylene. So here we have 5 covalent bonds are there. So let's plug in C2H2. So 4 times 2 minus 2 plus 1, 8 minus 3, that's equal to 5. You can verify this with the higher alkyne too. Okay. So in summary, we got 3 different general formulas to calculate the number of covalent bonds. So number of covalent bonds. If it is an alkane, it is 4n minus n minus 1. If it is an alkene, then 4n minus n. If it is an alkyne, then 4n minus n plus 1. So this n minus 1, n and n plus 1, they all give us the number of shared covalent bonds. Which we need to subtract with the valency, total valency of each carbon, and then we will get the total number of covalent bonds. Okay. So if you do like this video, consider subscribing it to Chem Media. Thank you.